Hi, I'm Mr. Huber, and in this video I would like to talk about exercise 1a. The diagrams below show functions whose form is a sine transformation or a cosine transformation with a, b, c, and d as stated. State for each graph a correct transformation of the sine and cosine function. Well, you need to know what the original sine and cosine function looks like. Well, this is the original sine function. It starts here at 0, 0, and it goes to 2 pi in this wavy-like shape. This shows a bit more than one period length. Here for the cosine, it's very similar. It starts at 0, 1, and it goes to 2 pi 1 in this wavy shape. Okay. So if you want to start with sine here, you look at a starting point here. Look, the middle line is exactly the x-axis here. So it has not undergone a vertical shift. So d is 0, no vertical shift. No vertical shift. Here we go. Well, it has undergone a horizontal shift because it starts at 1 instead of at 0, 0. So here, C is 1. Horizontal shift. Horizontal shift. 1 to the right. Now the amplitude, well, normally it would go up to 1. Look, it would go up to 1 and down to -1. But this one goes up to 4 and down to -4. That's why you can know that the middle line is right in between those two. So A, the amplitude, is 4. The amplitude. And now the last one is the period length. Okay, well, you know the period length and B are linked by this formula. Well, you need to know B, but well, you can't see it from the drawing, but you can see the period length here. So you can read it off the drawing because you see it starts here and it stops here. So the period length is 4. So you can write 4 is 2 pi times B. Now you need to isolate B. Well, that's very easy. 4B is 2 pi and B is pi halves now. 2 pi divided by 4, that's pi halves. So now you can state your sine function because you know A, B, C, and D. So your sine function is in fact 4 times sine, and then your B pi halves, x minus 1, translated to the right, plus 0, or just 4 sine pi halves x minus 1. You don't have to write the 0 if you don't want to. So this is your sine transformation. But you could look at this as being a cosine transformation. But then it would start at a high point. So it could start up here. And the amplitude is the same thing, still 4. The horizontal shift is now different because it starts at 2 instead of at 0. So for the cosine transformation, D is still 0. It has not been shifted up or down. C is now 2 because it starts at 2. The amplitude is still 4. And the period length, well, is still 4 as well. Look, from here to 6, from 2 to 6, that's 4 period length. So you can still know that B is pi halves. Still the same thing because it's 4 is equal to 2 pi over B. Well, if you isolate B, you get 4B is 2 pi and B is then pi halves. So the function, when written as a cosine transformation, is 4 times cosine pi halves x minus 2 plus 0. You don't have to write that. So you see the starting point is now at 2, 4. Here the starting point was at 1, 0. But you could say, well, I could have started here. Yes, you could have. That's why state for each graph a correct transformation, not the correct transformation. There are several. You could have said, well, why not start here? Okay, why not start at -2? That would have been 4 cosine pi over 2 x plus 2. Or you could have started here. You could have said f of x is 4 times cosine pi halves x plus 6. These are all the same functions. You could have done the same thing for sine. You could have started here. You could have said, well, f of x is 4 times sine pi halves x minus 6. In that case, you would have started here. But normally we take the first one to the right, okay? So this would be the one I would go for. Same thing here. So let's highlight this cosine function. The cosine function that we're looking at, the red one, is this one here. Okay. Well, it's all of it, but we're starting here. It describes all of it, but we're starting at 2. So that's the one here. And the cosine at the sine function we're looking at is in fact starting here. So let's do it in a wiggly shape here. And it goes to 5. Okay, so that's this one. So the only thing you have to do is you have to read D, C, and A of the diagram. You have to read the period length of the diagram. And once you have the period length, you can work out B. So it's not too difficult. See you in the next one.